All right, this is part one of two on mechanical advantages, counting tensions, and estimating system efficiencies. This is going to be a quick talk about counting tensions in a mechanical advantage system or an MA. For some, this technique is used when first learning mechanical advantage systems so they can see how the weight and percentages are distributed throughout the system. For others, it's used for determining the mechanical advantage of more complicated raking systems like Spanish Burtons. And for others, it's used as a quick means to determine what kind of force is being placed on the anchor depending on what you're setting up and what the change of directions actually do. But we first have to grasp this concept of counting tensions before we can move on to counting or estimating system efficiencies. This is just going to be a quick review. This is kind of presuming that you know a little bit about mechanical advantages, so this will just kind of bring things into the forefront here before we start talking about some of the procedures. So from left to right, we're going to go through this. This graph is going to show the behavior and dynamics of various mechanical advantage systems. This shows the force requirements and distance of pull required to move a load 1 foot. So on the bottom here, you can kind of see how we have the 1 foot marker for each one of these systems, and we have a 1-to-1, 2-to-1, a 3-to-1 z-drag, and then obviously we have a 5-to-1 complex. So when we're looking at a simple 1-to-1, you'll see that some people will count mechanical advantages as simple systems. It's pretty easy to do. You just can kind of count how many lines are supporting your load. Remember at the top here, when we pull our rope out, where that end of the rope connects to will help us determining simple one rope system mechanical advantages. So if the rope starts at the load, right, we're going to have an odd system, which we see right here on our 1-to-1. We also see that on our 3-to-1, 5-to-1. If the rope actually starts at the anchor, then our mechanical advantage is going to end up being even. So let's walk our way through this real quick. So on the far left here, we have a 1-to-1 system. So we have the load, the rope starts at the load, comes up through our progressive capture, and then is pulled down. So the direction of force is going to be down. In a 1-to-1, we're not really getting a mechanical advantage. We'll actually learn that we get less than a 1-to-1 when we're looking at efficiencies because of the friction in the pulley. But for our purposes right now, all we have to do to move this load 1 foot is pull 1 foot here. So if this load is 200 pounds, we're going to have to theoretically put 200 pounds of force on this to move it. So the force that we're hauling as a hauler is going to be equal to what that load is when we're talking theoretical systems. And to be able to move it 1 foot, we only have to pull 1 foot. When we look at a 2-to-1 system, theoretically this is going to cut the weight of the load in half, although now we have to pull 2 feet to be able to move that load 1 foot. So just like anything in physics, we have to increase the distance. So if we're talking levers, right, the longer that lever, the bigger the EMA is going to get as long as we're pulling on the end of the lever. So in this case, in rope, we're going to have to pull greater distances to be able to get that mechanical advantage. So for us, we're going to have to pull 2 feet to move this load 1 foot, but theoretically it's going to cut our weight in half. So with a 200-pound load, we're roughly going to have to be pulling 100 pounds. The other 100 pounds is going to be on this anchor. When we're looking at our 3-to-1, right, we can see that there's 3 ropes that are supporting our load down here. This actually kind of creates our new load here whenever we put a z-drag system in there. So from here we got 1 line, 2 lines, 3 lines, so we know it's a 3-to-1, and we'll be counting those tensions here in a little bit. But on a 3-to-1, we know that we're going to have to pull 3 feet to move that load 1 foot. The advantage of that is we're theoretically cutting that load's weight down by 1/3. So what we're pulling is 1/3, and then the other 2/3 is going to be on the anchor here. Now this is a 5-to-1, so this is one of the reasons that a lot of people get into counting tensions, because once we get into complex mechanical advantages, we can't count the lines any longer. So what we have here is a 5-to-1, and we'll talk about how to count tensions to get that. But on a 5-to-1, we're going to have to pull 5 feet of rope to move that load 1 foot. The good part about that is the theoretical force that we're going to have to apply is basically 1/5 of what that load is. All right, quick overview, got to go over this. This presentation assumes that the reader has a basic understanding of mechanical advantage rope systems. We'll be counting tensions within a mechanical advantage system to determine the theoretical mechanical advantage. A theoretical mechanical advantage assumes that we live in a frictionless world, which we all know is not correct. So friction acquired within a pulley and/or a prusik is ignored when we're counting tensions. There are sometimes easy ways to find an MA of a simple or compound haul system. You may count the lines supporting the load of a simple system, or break down a compound mechanical advantage into its individual simple MAs and then multiply them together, and we'll see those here in a couple slides. The problem arises when we look at a traditional complex Hall system and some of the Spanish Burton variants. Concepts to remember: we're always going to start counting tension from the Hall line, which is where your hands are going to grab that rope to start pulling, and we're going to work our way back through the system and end at the load. The number that we hit on at the load is what that mechanical advantage is going to be. It's just a ratio between what our input is and our output. So when we write that 5 to 1, the 1 is going to be our input, the 5 is what the output, resultant output, is going to be. We'll always start with one tension on the Hall line. Once we know the mechanical advantage, 3 to 1, 5 to 1, 6 to 1, we can then input estimated weight values if desired. So like we mentioned before, if we know that it's a 2 to 1 that we're hauling on and we know our load is approximately 200 pounds, we can then divide that 200 by 2 and realize that we're going to be pulling on our haul line approximately 100 pounds. All prusiks, except at the PCD, the progressive capture device, are going to be a point to add numbers. So we stop at all rope grabs to see if we need to perform any addition within our system, and hopefully this clarifies once we start getting this thing going. All right, pulleys are a force multiplier. So the pulley, we always hear that a moving pulley is what adds to the mechanical advantage, and that a stationary standing pulley, which is usually at an anchor, doesn't do anything to our MA, which is correct. But no matter, regardless of where that pulley is, a pulley is always going to magnify force, and we're going to see that in when we count tensions and when we count efficiencies. So as kind of a quick cheat, we can always look at whatever pulley you have. The majority of all pulleys have this, something talking about what it's rated at on the front. So whether this is 30 kilonewtons in the point that we have here, or it's 36 kilonewtons or 40 kilonewtons, whatever that number is, you're always going to see it with half that number in and half that number out. So we're talking about 30 kilonewtons here. So if 15 goes into this pulley, then 15 has got to come out. And what we're going to have is 30 in this case right here at the apex of it. So in our cases, we'll be counting tension. So we'll have one tension coming in. We'll always have one tension coming out. And then we're going to have two tensions up here. So we just simply add these two numbers, which in our case is a counting tension, will be 1 and 1. But as we get into larger numbers, we may have a 3 goes in, 3 comes out, and then we're going to have 6 at the top. So these numbers will get added together to see what this number is that's going to be sitting on your prusik or potentially your anchor. So remember Newton's third law when we're doing this. The MA is the final number that's going to be at the load, and don't ignore the anchor number. And we'll see in some cases the tensions that are on the anchor are greater than the tensions we're actually hauling. All right, so let's get started talking about counting tensions. So like we said before, we're always going to start on the haul line, and we're always going to start with a 1. So remember, as we work our way from the haul line all the way back to the load, we're going to start this on the left and work our way through. So if a 1 starts off with our haul, we're always going to do 1 tension is coming in. So as that goes up to our first pulley, which is our progressive capture, if 1 comes in, 1 has to come out, and that's going to leave us 2 up here at the apex. So just like we talked about before with the 15 and 15 equals 30, so we're using 1 tension now, so we're using tension. So if 1 comes in, 1 has to come out, and 2 is left here at the apex of that. 1 comes down, and 1 terminates at the load, so we know we have a 1 to 1. So now we're going to move on to another one. So like we said before, we're always starting at the haul line. We're starting at the green 1. So we start hauling with 1 tension. If 1 comes in, we know that 1 has to come out. And at the apex, we add those numbers together, and we know we have a 2. And we know we have a 2 to 1 mechanical advantage, but that 1 continues up, and so 1 tension is here. So when we think about a 2 to 1 and we cut that weight in half, the anchor has 1 tension, we have that other tension. So no matter what that load is, if it's 100 pounds, we got 50 and 50. If it's 200 pounds, we got 100 and 100. So 1 comes in, 1 comes out, 2 is left at the load. We always count the number that terminates at the load, so we know it's a 2 to 1. Now, this is basically looks very similar to this next one, except we come back up to the anchor and do a change of direction. So this is actually going to be a 2 to 1 with a change of direction. This adds a little bit of confusion on people when they're first learning mechanical advantages, because they start going, oh wow, we just added this, so is it a 3 to 1? What is it? So you'll see it's actually the same thing. So as we start off with a 1, because this is our haul line, if 1 comes in, 1 has to come out, and we have 2 at our anchor. We continue on, 1 comes down, 1 comes down, 1 comes in, 1 has to come out, and we have 2 at our load, which means it's a 2 to 1, and then this one comes up here and terminates. So because we put a change of direction in and we're pulling against our anchor, although we have a 2 to 1 down here, we actually have 3 tensions up here at our anchor. So if we wanted to think what that really means, let's say our load was 200 pounds. So we know that we're inputting 100 pounds here. So if we input 100 pounds, we know that we have to have 100 pounds coming out. And that means we have 200 pounds right here. So 100 comes down, 100 comes down, 100 goes in, 100 has to come out, which means we have 200 down here, which is accurate. And then that other 100 comes up here. So when we add those together, we actually have 300 pounds of force on our anchor, yet we're hauling 200 pounds. And it's because of that last change of direction or redirect that is adding that extra weight to our anchor. All right, getting into some more complicated systems. So we're going to start here at our haul line. We're pulling with the anchor, and you'll see when we pull with the anchor that our anchor weight is typically not going to be exceeding what our weight is down here. So with a 1 to 1, or with the starting off with 1 tension, we have 1 that comes down, so we work our way to the load. 1 comes in, 1 has to come out, and now we have 2. That 2 that's at that apex of that pulley is actually going to sit on that rope grab. So whether that's a T-block or whether that's a prusik, a 2 is just going to sit there. And if you remember when we were talking about our overview, anytime we see a rope grab, that's going to kind of equal a plus sign or an addition sign in our head. So 1 comes in, 1 comes out, 2 is on the prusik. 1 comes up, 1 comes up, 1 goes in, 1 has to come out, 2 is sitting on the anchor point. 1 comes down, and as 1 comes down, we meet the rope grab, which is a plus sign. So 1 plus 2 is going to be 3. So we have 3 tensions from this point of the rope. So we have 1 tension in here, we have 2 tensions here. When these meet, we have 3 tensions that go to our load, telling us that we have a 3 to 1, and this is a Z-drag configuration. So continuing with that, we basically put the change of direction in over here. So let's figure this one out. 1 starts, so 1 comes in, 1 comes out. We have 2 at our anchor. The 1 continues down. If 1 comes in, 1 comes out, and we have 2 sitting on our prusik. As 1 comes in, 1 comes out, and we have another 2 tensions on our anchor. That 1 continues down, 1 continues down, it meets our rope grab, which has 2 sitting on it, so 1 plus 2 is 3. So we still have a 3 to 1, it just has a change of direction. But what we can see here is because we're pulling against the anchor, we actually have an extra tension on our anchor, so we're putting more force on our anchor than what we actually have on our load. The last one here is going to be a Spanish burden. So this is one of the complex variants that we were talking about before. You're going to see this sometimes in some mountaineering configurations. You can use a cordelet, you can use a sling, different things are put in as this rope. So the red rope, the red color signifies another rope, and the yellow is our main line. So once again, we're going to start here on our tensions. Just so you know, right here, this signifies that our whole rope length is run out, and this is the terminal part of the rope. So there's not enough that we can build a MA system off of. So we add this second portion on. Start with a 1 on our haul line. So if 1 comes in, 1 has to come out, and we're left with 2 on this prusik. And this one is actually terminates here, so this could be nothing but a figure 8 knot or a clove hitch or anything like this. So 1 comes in, 1 comes out, and 1 terminates here. So we just have 1 sitting on that prusik. Go back up to our 2, which is being pulled. So 2 comes in, 2 comes out. That leaves us 4 up here on our anchor. That 2 continues down. It meets with that prusik, which has 1 on it, which gives us a 3 to 1 Spanish burden. Okay, moving on. The first one we're going to hit is on the left. So we broke out these 2 pulleys. Typically what you're going to find in a 5 to 1 simple mechanical advantage is this is going to be a double pulley. So we kind of broke it out so we can count it a little bit easier. So each one of these is 1 separate sheave that's in a double pulley. So once again, haul line, we know that we are pulling with our anchor, so we know that that force on our anchor isn't going to be magnified like it is when we're pulling against it. So we start with 1 tension. 1 tension comes in, 1 tension comes out, and 2 is left on one of these sheaves. As 1 comes up, 1 comes out, and the first 2 is left on our anchor point. 1 comes in, our second sheave of our double pulley, 1 comes out, and we're left with another 2, which equals 4. So 4 is sitting on that prusik or rope grab of your choice there. 1 comes in, 1 comes out, 2 is left, so that means we have a 4 total on our anchor. That 1 continues down, meets up with our rope grab. That is 1 plus 4, which means we have 5 tensions. So that is a 5-to-1 simple mechanical advantage. And like we said before, that's a double pulley. Now we're going to look at another 5-to-1. This is a 5-to-1 complex, which we use quite a bit. Once again, we are pulling against the anchor, so we know what to expect, a higher number up here. So when we start there, we start with a 1. 1 comes in, 1 comes out, 2 is left here. So 2 is sitting on that prusik right now. 1 comes down, 1 comes out. 2 is sitting on this prusik. 1 comes up, meets the 2 that's sitting on that prusik, and we have 3 in this segment of our rope. So 3 is going to come in. 3 has got to come out, which leaves 6. So 3 plus 3 is going to be 6. So we have 6 here on our anchor. That 3 continues down the line, meets up with the 2 that is in our rope grab. So 3 plus 2 is 5, and we have a 5-to-1 complex MA. Now we're going to go to a 5-to-1 crevasse. Some people call it a 5-to-1 Spanish Burton by utilizing the second line. 5-to-1 crevasse is what it typically goes by. Not too uncommon in a lot of mountaineering techniques, especially when you're just using that mechanical advantage to help a climber get through a crux or something like that. So we start with our 1 on our haul line. So here's our haul line. So 1 comes in, 1 has to come out, and we are left with 2 that's sitting into the force here. So while we're pulling that, that 2 comes in and 2 comes out. So that 2 terminates up here, and we are left with 4 sitting right here. That is because 1 and 1 equal 2, 2 coming in, 2 coming out equals 4. So 4 is sitting there on that prusik. Now when we go back to our original system here, that 1 that came out, 1 goes in, 1 comes out. We have 2 there, which is going to leave us with 4 at the anchor. 1 in, 1 out, 1 comes down and meets with the prusik that has 4 tensions on it. 4 plus 1 is going to be 5, so that is a 5-to-1 crevasse. All right, getting even more awkward. We have a 7-to-1 Spanish Burton here. Looks pretty complicated when you look at it. Basically what we have here is 2 terminating points. So we have if you can imagine, we have potentially a clove hitch that goes through here, or we could technically say we have a short piece of cordelette that locks off. So this is tied off, and this is tied off, and this is tied off, and this goes through as our haul line. This is one large piece of rope that terminates right here. So when we set this up, we start it with 1 because this is our haul line. So 1's going to come in, 1 is going to come out, and we have 2 sitting right here. That 1 continues down and terminates right here. So now we have that 2. That 2 comes in and 2 comes out. So note that we don't have pulleys here, but we have carabiners, which also are going to magnify that force. So we treat them just like they're pulleys. So 2 comes in, 2 comes out, and now we have 4 sitting there. 2 plus 2 is 4. That's going to be sitting on that prusik. That 2 comes down and it terminates because these are acting independently of each other. 1 plus 2 is equal 3. So 3 is going to be sitting on our rope grab. Come back up to where our 4 was. If 4 comes in, 4 has to come out, and we have a total of 8 on our anchor. That 4 is going to be coming on down. That 4 meets with the 3, and we have 7. So that's a 7-to-1 Spanish Burton configuration. And we have 8 tensions on our anchor, oddly enough, because we're pulling against it. When we come over here, you're going to see this is a compound. So if we break it down, we can see that this looks just like a 3-to-1, and we're usually pulling. So forget that these 2 pulleys are here. That's a 3-to-1, but if we look at it, we actually have another 3-to-1 pulling on top of a 3-to-1. So we can break this into 2 systems. We know if we have 2 simple mechanical advantages working together, and like that, that's a compound. So we have a 3-to-1 pulling on a 3-to-1, so we know it's a 9-to-1. But to double check our work, we're going to start at the haul line, and we're going to see that we have 1 tension coming in here. So 1 tension comes in, 1 tension has to come out, and we have 2 sitting right here on the prusik. As 1 comes in, 1 comes out, and we have 2 on this anchor spot. 1 continues down, meets up with the 2, and we have 3 at this portion right here. So if 3 comes in, 3 has to come out, and we have a total of 6 sitting here on this prusik. So 3 and 3 is going to be 6. As that 3 comes out, 3 comes in, 3 comes out, we have a 6 on our anchor. So when we add these 2 together, we have 8 tensions there. That 3 continues down, and that 3 meets with our 6 and gives us a a 9-to-1 compound. So we've talked about simple mechanical advantages, we've talked about complex mechanical advantages, and that's our compound mechanical advantages, where they're compounding each other by putting an MA on top of an MA. Lastly, we're just going to talk about piggybacking. So this is pretty common too. This is a 4-to-1, 5-to-1 system. That's the Phantom Hall kit. You can see an Aztec version of that with a little bit bigger diameter that you'll see some teams using. And in the end, what happens is we have one main line that is here and terminates right here, and then we just take our separate system that's already pre-configured into a mechanical advantage and we attach that onto our main line. So no matter what, we recognize that this is just a 1-to-1, so this isn't adding any kind of a mechanical advantage to us whatsoever. So when we add our, in this case, 3-to-1 mechanical advantage onto that, we'll go through, but realize you can put a 4-to-1, 5-to-1. You see a lot of different systems for confined space or for simple mountain hall kits. So we start with our hall line. That's 1. 1 tension comes in, 1 tension comes out. That 2 is sitting on that prusik. 1 comes in, 1 comes out. We have 2 on our anchor right here. As that 1 comes down, it meets with the 2, and then we have 3. So because this adds nothing to it, this is not a mechanical advantage, this is just simply pulling on a main line, we just simply have a 3-to-1. If this was a 4-to-1 coming down, we're just going to have a 4-to-1 or a 5-to-1 depending on what you have. We just have to remember, as we're pulling that, we're going to get slack in this whole area. Whatever is beyond where our rope grab is, we're going to get slack. So before we can actually reset our piggyback system, we have to take the slack out of this by pulling that through, having it capture into our progressive capture here, and then this will be holding our load where we can actually reset this for efficiency. So that is the end of Counting Tensions Part 1. What we're going to do is build on that for our second podcast or videocast and show how we can use that same technique of moving our way through our system, but this time we're going to actually be looking at what the actual efficiencies are of various pulleys and various devices that we may be using in our system. Thanks.